Hello, my name is Alex. I've been making games for 9 years, and in this course I'm going to teach you how to make your dream FPS game so you can release it or even sell it and, make money like I have. I've made a multiplayer FPS with over 800,000 downloads. I made a course for a YouTuber called Blackthorn Prod, and this right here will be the best course on YouTube on making a multiplayer FPS in Unity for free. We'll add all kinds of content, player models, leaderboards, and it'll go further than anything out here on YouTube. Now, super quick, if you haven't already, we need to install Unity. So search up unity.com, click the download here, download for Windows or whatever it is, download the Unity Hub setup. You'll get a program that looks like this. This is Unity Hub. The first thing you'll need to do is to install an editor. So go to here, click install editor, install the latest official release, and install the Microsoft Visual Studio as well. That's all you need. Agree to the license, click install, and you'll have Unity. Alright, with that done, let's get started. Alright, let's get started. So click new project, choose the latest LTS version. Let's name it multiplayer. Nope. Multiplayer FPS. Make sure to choose Universal 3D. Click create project. Now, while that's creating, we're going to need to do some setup. So the first thing we need to set up is the server. So search up Photon PUN right here. So this is the server backend that we'll be using for our multiplayer FPS. If you want to know about the pricing, just click here. And it's actually very fair. So under 20 concurrent users, it's totally free. And I used this for Paint Warfare for the longest time. Then for $100, well, $95 a year, you get 100 concurrent users. So that's 100 users at the same time, which is equivalent to around 40,000 users every month playing your game, roughly speaking. Maybe a bit more, a bit less. But if you're reaching this amount of concurrent users for Paint Warfare, you'll have no issue at all paying for server costs. Let's say your game completely blows up, it gets covered by YouTubers and stuff like that. Well, here's the 1,000 concurrent users plan. Let's just say $200 a month. That's suitable for 400,000 monthly active users. So 400,000, let's say, let's be super pessimistic, 0.01. So 1% of players buy something, and people that buy something spend an average of $5 on your game. You're making 20K a month. Like the real value might look more like, I don't know, 3%. They spend $10 on average. It's 120K. So you'll have no issue at all paying for servers. These servers are really fairly priced, and you can use the free plan until you get enough players. So yeah. So if that sounds good to you, head over to this dashboard here. You may need to create an account. And what you're going to do is click create new app. Choose multiplayer game. Choose PUN as the SDK. For the name, you can choose whatever you want. I'll call it an FPS tutorial V4, blah, blah, blah. Just click create. Oh, where is it? There you go. Find it and copy the app ID. We'll need this later. Then we need to import the package, which we will use to just simplify multiplayer inside of Unity. So go to the Unity Asset Store, search up Photon PUN 2, go to Photon PUN 2 free, make sure it's PUN 2 and not PUN Classic, so PUN 2, and just click Add to My Assets, like so. You may need to sign in, but once that's done, it'll be added to your assets, and you can click Open in Unity, or you can go to Window, Package Manager. You'll open this up, go to My Assets, and search for PUN 2. All right, download it, and import it into your project. Just hit Import. Click Yes. And you'll get this PUN setup wizard popping up. If you don't see it, just go to Window, Photon Unity Networking, PUN wizard. Click Locate Photon Server Settings. You'll get this. Expand this, And in the app ID pun, what you'll do is copy your app ID, paste it in here, and also just set a fixed region. So we'll just set EU. Yeah, there you go. So you can set this to US, AU for Australia, whatever you want. If you don't set this, then it'll just connect to the server that's closest, which may not be ideal. Say you're playing with a friend from Europe and you want to test your game with your European friend, but you live in Australia. Well, they'll connect to EU servers and you'll connect to Australian servers and you won't be able to play together. So just set this to EU for now. We might add a region select in the future, but just keep this for now. Cool. The next thing you will need is basically sort of like a free gift I've prepared for you guys to make stuff that looks acceptable. So I've made a pack. Basically, it has particles, it has 3D models, it has the character model, which we'll use, it has the animations, it has sound effects, and it also has a map, which we can use for development and testing. So you can see all that. Just click import. Now this pack will be downloadable below this video, I think, or however else I figure out to share it. It'll be on screen, how to get it. There we go. And we'll just open the testing map that I prepared. So go to the pack, go to scenes, and just double click on the map, and that will open it. And this looks fine to me, but if the lighting just looks all black, go to window, rendering, lighting, and just click generate lighting, and it'll fix it up if it looks all black. There we go. Yeah, so I'll just walk you through everything. So this has no code, it's just the map here. It's called Sky Arena. We got the light. We got an empty game object for the room manager, which has no code yet. We'll fix that. And we have a camera for while we're joining. And we have just some UI. If you enable this and this pops up, make sure to click Import TMP Essentials. And import TMP examples and extras. If you don't see that, just go to Window, Text Mesh Pro, and you can use these two. Cool, so there's a connecting UI, and there's a UI for choosing your name, which we will implement in due time. So let's create the script to connect to the server. So click on your room manager, add component, and we'll create a new script called room manager. Boom. Just wait for it to create. Open it up in Visual Studio or Rider or whatever you're using. All right, so let's get started. So we have this blank script and we want access to some extra functions to do with Photon PUN, which is the framework we're using for multiplayer. So at the top, we'll add using Photon.PUN. And when the game starts, we want to first connect. So I'll just give you a brief rundown of our plan for the script. So first, we connect to the master server. 2, we join the lobby. So in Photon PUN, which is what we're using, the lobby is where you can view all the active games / matches. In Photon, these are called rooms. Then in the lobby, you can join one of the rooms. And then once you're in the room or in the match, you can spawn the player. So for this project and for what I did in Paint Warfare, each room is basically a different map. So Dunes is one game going on, it has one room code. My snow map has a different room code and it's a different game going on. So that's what we'll do. This will be really simple. It's actually a lot less daunting than it looks like. So first we want to connect to the master server. To do that, we'll do Photon network. And if that's red, make sure to be using Photon.PUN. So Photon network dot connect using settings and semicolon, like so. Now we want to run part 2 once we're done connecting. So how do we know once we're done connecting? Well, similar to how start is called by Unity when the game starts, We have functions that are called by Photon when certain events happen. And to access those functions, we need to change mono behavior to mono behavior PUN callbacks. So mono behavior PUN callbacks. This is crucial. And then we'll get access to public override void on connected to master. All right, so we connected to the master server. And from here, we then want to join the lobby. So we'll do Photon network dot join lobby. And then once we've joined the lobby, so we'll do public override void on joined lobby. We want to join one of the rooms. So we'll do Photon network dot join or create room, right? And it wants a room code and some room options. So for the room code, we'll set one in the inspector. So we'll do public string room code equals, and we'll call it map1 for now. In each map, we'll change this code, obviously. So you don't have players from the desert map, the snow map, the factory map, the island map, whatever, all showing up in every single map, which would make no sense. So you can actually like separate the networking between rooms. That's what this is for. So we'll take this room code, pass it in here. And then it wants two more things, room options and type to lobby. We actually don't need these for now, but we will use them eventually. For now, just pass in null. That just means we don't need this. Then once we've joined or created the room, we want to spawn the player. So the method for this is actually public override void on joined room. Make sure the capitalization and all that is correct. Otherwise, it just won't work. Now, we could run this and it would hopefully work, but we would have no idea. So let's add some debugging statements so we can see if it's actually working in this console window. So first we'll do debug.log connecting. Then we'll do joining lobby, joining or creating room, and join room, spawning player. Save that, and let's give this a test. So if you go to your console window, make sure this is enabled. You'll see these messages. So connecting, joining lobby, joining or creating room, joined room, spawning player. Perfect. That's the netcode. Hopefully it's much simpler than you most likely imagined. This package is truly a godsend. It just makes stuff so much easier. So now let's spawn our player. Now to spawn a player, we firstly need a player. So for now, our player will just be a bean, and then eventually we'll replace it with a proper model. So right click, create 3D object, capsule, boom. Let's just position it. Let's make it taller, 1.5, looks good. We'll rename it to player. Then we'll add a rigid body component. And we don't want our player to just fall over, like sideways and roll around. So under constraints, make sure to freeze rotation on the X and on the Z. So we only rotate on the Y. Then right click on the player and create a camera. We'll call this FP for first person underscore camera, like so. Just move it up. Let's position it, I don't know, 0.7. Like so. So it's from the head of the player. And if you played this, you couldn't move around or anything like that. So let's fix it. Now in the pack that I've made, I've put together a super bare bones movement and looking around script so we don't waste time reinventing the wheel. I'll explain it obviously, and then we'll expand on them in future videos. But this is just so we don't waste time making something basic. So on your player, drag on the movement script. And on the camera, drag on the mouse look script. In the mouse look, this is very important, drag in the player as the character body game object. And under your room manager, let's just disable the room camera for now, just to make sure that everything is working. Hit play. And we can look around, we can walk around very slowly. Very nice. I'll just increase the speed to 8. Alright, so just a quick rundown of the script. Let's look at the movement script first. So here we define the walk speed. This will slow down a bit. Then we have the jumping force. So this will affect how high you jump. Then we have some private variables for storing stuff. So we get the rigid body components attached to the player, right? On the same script. The script, right? So the script gets this from this player. In the update method, so in every frame, we first gather the input. So for the x-axis, we're gathering horizontal, so that's A and D, or the arrow keys. For the y-axis, we're gathering the vertical, and we're normalizing it. So normally, if you're holding W and D, the input would be 1, 1, right? And if you're just holding W, the input would be 1, 0. If we just directly applied 1, 1, then you would move faster overall diagonally because you're moving in 2 directions at the same speed as you would normally be moving in 1 direction. So what normalizing does is it changes this to like 0.707, 0.707. So effectively, the magnitude overall of both of these is 1. So 1, 1, yeah. Here we also check if we're pressing space and we're touching the ground, well, we can jump. In the fixed update, so this is called every physics update by Unity, this method, similar to update. So updates every frame, this is every physics frame. Well, we're going to get the rigid body and we're going to apply a force to it to move it, right? And this force is figured out by this calculate movement function. So this is actually our movement code. So we find our target velocity, which aligns our input, so left and right, forward, backwards, to the rotation of the player. So that's what transform direction does. And we multiply it by the walking speed. And here we just make sure that you can't just instantly go like this way, then this way, that like just super quickly change speed. So it smooths it out a little bit. And here we're saying inputs magnitude is greater than 0.5. So you're making some inputs on WASD. Then we'll pass through the change in velocity. Otherwise, we'll pass through 0. So we won't add any force to the player. On collision stay happens every physics frame that our player is staying, touching something. So we're setting is grounded equals to true. And then at the end of the physics frame, we're resetting it equal to false. So basically the loop is on collision, stay cold equals true. Then we run code, then we reset it to false. And this happens into a loop, right? So this is called we're grounded. Then we run this code based on if we're grounded or not. And then we reset it to false at the end of running the code. And then let's say our player was jumping and they're not touching the ground anymore. Well, this wouldn't happen. You run the code, it's false. Yeah, cool. Here's our mouse look. Basically, it just rotates the player if you look side to side, and just rotates the camera if you look up and down. It also has some code for smoothing if you want. It's not really necessary in FPS games. And in here, we lock the cursor on start, which basically just means that the cursor will not be visible and it'll stay in the same place, even if you move your mouse. Yeah, cool. So now we want to spawn our player over the network. To do that, we need to put our player into a special folder. So right-click, create, new folder, and make sure to spell this exactly as I have, RESOU resources. All right, make sure it's spelled exactly like this. Then drag your player into this resources folder, and we can delete it from here. We can re-enable our room camera, and on our player prefab, just double click it to open it. Click add component. We'll add a Photon view component. So this allows it to be spawned by Photon. And also we want to add another component, which is a Photon transform view, which will sync this transform component. So if our player moves around, if it rotates, this Photon transform view, oh, where is it? Yeah, this Photon transform view will sync it. So we're synchronizing the position, rotation. We don't need scale at all for now. We can save that. Now there's one more thing we'll need to do after, but we will talk about it later. So in our room manager, we want to spawn our player. So add a public game object player. And now here we want to spawn our player through Photon in onJoined room. So we'll do Photon network dot instantiate, and it wants a prefab name. So the name of the prefab inside of our resources folder. So we'll do player.name. Then it wants a position. So we'll make a public transform spawn point. And for the position, we'll do spawn point dot position. And it also wants a rotation. Now we don't really want to rotate the player when we spawn them. So we'll just do quaternion.identity, which is a rotation of 0, 0, 0. Add a semicolon here. And in our room manager, we'll drag in our player. And we also need to create a spawn point. So let's create one. Right click, create empty. We'll call it spawn point. And a cool tip is if you click here, you can make it a dot, so you can see it in 3D space. Let's just reset its position. There we go. And make sure that this point is above ground. So it should be fairly above the ground, like so. And make sure to drag this spawn point into our spawn point transform, like so. Now also, when we spawn our player has a camera. So we want to disable the room camera once we've spawned our player over the network. So we'll get a reference to our room camera. We'll do public game object room camera. And we'll just add some space between these two things in the inspector. So in here, we'll do room camera dot set active false, like so. And we'll drag in our room camera into here. So let's test this out, and hopefully our player should spawn at the spawn point. Boom, look at that. Now what I'm about to explain next is a sort of hard concept to grasp, but it's super crucial that you really have a good understanding of how this works. So to demonstrate, what I'm going to do is create a build of this game. So I'm going to go File, Build Profiles, and let's go to the pack, let's go to Scenes, and drag the map, go to Scene List, and drag the map into Scene List. Let's delete the sample scene. So we just have the map in our scene list. Let's go to Windows or Mac or whatever you're using and click Build and Run. And I'll just build this on my desktop. All right, so when testing, make sure to allow network access. So this all looks normal when you have one player, right? But if you have two, something very strange will happen. See, I'm controlling both players at once, even though I'm not this guy, right? And I'm looking through the wrong camera, and there's two cameras active at once. So maybe try think about this and try to understand what's happening here. And this is an issue that we'll have to solve, and I'll explain how to solve it, but just try think to yourself why this has happened and how we might go about solving it, and then I'll explain it to you. We've told Unity, hey, create this player word for word exactly on both people's PCs. So when I connect, I'm saying, yep, instantiate this player exactly, total copy on both people's PCs. But there's an issue. Because when you do that, both players have a movement script and a camera. Now, for when you're controlling the player, yeah, of course, you want a camera so you can look through the player, and you want to have movement so you can move. But on the remote PC, so your copy of the player on someone else's PC, you don't want them to be able to control you or your camera, right? So the solution is for when the player is yours on your PC, you want the camera and movement to be enabled. But when the copy of the player is not on your PC, then you want the camera and movement to be disabled. The proper term for this is this prefab is the local version of the prefab, so you created it, and then there's the remote version of the prefab. So you created it on someone else's PC using this function. So to handle all this logic, we'll create a new script on our player called player setup. And inside here, we'll add a public game object FP camera, and we'll add a public movement, so a reference to our movement script called movement. And on start, so the first frame that this player is created, what we want to know is this version of the player the local version, or is it the synced version on someone else's computer, right? And you can check that using this Photon view component. Now, to get a very easy way to access that, sure, we can do public Photon view, blah, blah, blah. But what we can actually do is in here, we can add pun, so mono behavior pun, and at the top, add using Photon dot pun, right? And we'll just call if Photon view dot is mine. So is mine means I created it, and this is my local copy. Well, we'll set fp camera dot set active true, and we'll do movement dot enabled equals true, right? Else, so if it's not mine, we'll do fp camera dot set active false, and movement dot enabled equals false. Now, if this makes sense to you, you can actually simplify this by writing this like so. So these two things are equivalent. All right, the camera set active will be equivalent to if it's mine or not. The movements being enabled will be equivalent to if it's mine or not. So both of these are the same, just write it however you prefer. Now make sure that you drag in your camera and you drag in your movement, and let's save this. And if you press Ctrl B to build it, make sure you drag the map in as well, like I showed you. This will all work flawlessly. See, it's all working as expected. Now we'll improve the movement in a future video, but this is really cool. You should be really proud of yourself. We've synced two players over the network. We've added movements, and we've set up everything we need to know. You've learned how this all works, and we're ready to expand it in the next episode. So I'll see you in the next one.